Hi folks, Chuck Black here. We are doing 52 weeks of Python. This is week number 14. The topic for this week is how in Python everything is an object. And going along with that is the idea of mutability versus immutability. That's what we'll be talking about. As you see, what you're looking at here, it looks a little bit less conventional in terms of talking about devices and interfaces and IP addresses and all that stuff. That's because I've made it as simple as possible so that you can understand this topic. Now, this topic is probably not going to be a huge issue if you're brand new, but I do think that it will be useful for you to listen to it and understand it, certainly if you're going to go anything beyond beginner, and if you're going to try to expand your skill set into becoming a software developer, this is some of the fundamental stuff you'll want to be aware of. And if you are aware of it, it will put you leaps and bounds ahead of other people who don't spend the time to understand this. So hopefully this will make sense, make clear for some of you who have heard the term about everything being an object but didn't understand what it was. Hopefully it will make it clear. It will help you to fend off potential issues that you may have in the future and help you to understand exactly what Python is doing a little bit behind the scenes and why it behaves in the way that it does. So without further ado, here's the lesson. Okay, so let's get started talking about how in Python they say everything is an object. Now this topic goes hand in hand with the idea of mutability and immutability, so I'm going to touch on both of these topics in this lesson. Now, this is not an absolute rank beginner type lesson. This is more intermediate, maybe even advanced for some. So if you are new, just listen along and try to absorb as much as you can. I'm going to describe things 3 different times. I'll take 3 passes at describing it. If you're intermediate or advanced, then I think this is a useful thing to know. And as you grow in your software development skills, it's going to be important for you to understand how things work under the covers. So this is what we will be looking at. In your intermediate and more advanced programming endeavors, you will run into this situation at points in time, so it's helpful for you to understand it. Now, what we're looking at is my IDE. You can see the code that I've written for everything is an object. It probably looks like gibberish to you and makes absolutely no sense, which is why I'm going to have to describe it in a couple of other ways first before we come back to the code. You'll see that when you run the code, I've tried to put helpful comments in here to help you to understand. You see the word mutable, immutable, etc. We're looking at ID, which is something that will come into play when we look at a picture of this. So yeah, let's get started with first doing things via the Python interpreter. So what I'm going to do is I'm going to run Python 3. Now I am within Python. I like to do this from time to time just to see what actually is going on. I test how Python behaves in certain situations. Specifically, in this case, I'll be looking at how things work when I deal with integers, how I deal with lists, etc., and what certain lines of code in Python, what the effect is. So let me do this. I'm just going to say I equals 1. So when I say I equals 1, I came back with my 3 greater than signs, so that means Python's pretty happy about that. It's handy that I can just type in the letter I and it will print out the value. If I do that, you can see the value of I is 1. Let me show you something else, and this will become more clear why I'm doing this later. I can also type in type I, and what this will do is it will tell me, okay, what type of variable does Python think that I is? So that's good. Another thing I'm going to do is I'm going to say ID of I. That is going to tell me where in the computer's memory this variable called I, or the thing that I points to, is located. And you can see that it's at 978.4864. The number itself doesn't really matter, but as we'll see a little bit later, it will be a useful reference point when we try to understand what's going on. So here I have I is equal to 1. Now I'm going to say j equals I. So if I was to ask you, well, what's the value of j at this point in time? Then you would probably say, well, it's 1, and that's good. If I type in j, it's going to tell me that the value of j is 1. Now I'm going to do something different. I'm going to say I equals I plus 1. As you probably know, I could have written this I plus equals 1. It does the same thing. That's shorthand in software. So if you ever see that, that's the same as saying I equals I plus 1. So now at this point, if I was to say what's the value of I, you will be responding to your computer. The value of I is clearly 2. And you are correct. The value of I is 2. But now if I ask you what is the value of j, well, we can see right here, j points to I, right? So therefore, when I say, show me the value of j, and I've asked this in many classes in the past, sometimes even for advanced people, their answer is 1 or 2. I think it's always either 1 or 2. But just have a think about it. What's the value of j going to be? I'm going to print j right now. Let's look at what the value of j is. Okay, that may be a surprise to you. J is 1. And why is that? Well, it traces back to the idea of everything being an object in Python, and it deals with the idea of mutability and immutability. So let me do something else, and let's put our thinking caps on. I'm going to use the same variable names. I'm going to say I equals square brackets. That tells me that what I'm about to do is I'm about to create a list. I'm going to say 1, 2, 3. I equals 1, 2, 3. Now Python, because it is dynamically typed, it's okay with that. You remember I, when I did type of I before, it said I was an integer. Now I'm going to do type I, and it's going to tell me that it is actually a list. Okay. And if I just do I, it's going to print out I in this list notation with the square brackets. It's equal to 1, 2, 3. Now, once again, I'm going to do j equals I. And if I was to ask you what j equals, you'd probably say that it is equal to a list with the values 1, 2, and 3. And of course, you'd be correct. Now we're going to do something similar to what we did before. Remember when I was an integer, we added 1 to it. This time I'm just going to append one item to I. So now I'm going to say I dot append parentheses 4. So I'm calling the append built-in function on I, and I'm going to append the numerical value 4. Now if I print this out, and I was to ask you what do you think it will be, I'll give you a moment to think about it. You can hit the pause button if you want, but what you should see is open square bracket 1, 2, 3, 4, close bracket. And now that I've done that, you can see that sure enough it is. And now I'm going to say, what is the value of j? So sit here and think about this. Have a couple of ideas bouncing around in your mind. Of course, the foundation of all this is that everything's an object. A secondary thing that we're talking about is mutability and immutability. And what will the value of j be? Well, let's have a look. What you may be saying, when I and j were integers, and I modified I a little bit, and then I printed out I and j, they were different values. That's what we saw right up here, right? I, when I added 1 to I, its value is 2, but the value of j was still 1. Down here, I said that this is the value of I. I said j equals I, just like I did before, and it's the same value. And then I did I dot append, and this time, up here, I and j were different values. As you can see, down here, I and j are the same values. Why is that? I'm going to give you the answer to that And then we're going to depart from here and look at pictures, and I'm going to explain everything as an object. The reason is integers in Python are immutable. What does immutable mean? Well, when I give a class, I always say immutable is like my wife's opinion. It will never change, so it's fruitless for me to argue with her. And she thinks that that's funny as well. And I'm still married after, let's see, almost 40 years. So, yeah, that may or may not be a harmful thing for me to say. But immutable means it will never change. Mutable means that it can change. And if I were to say to you at the beginning, with your knowledge of something like this, I is an integer, can I ever change? Well, we just did an added 1 to I, and I became 2. Well, that's true, but I, what it was pointed to before, did not change because integers, as well as strings, are immutable. That means they can never change, and I'm going to demonstrate this to you with a picture in just a second. On the other hand, lists are mutable. You can change lists. So in our situation up here, when I said I equals I plus 1, Python threw away the old I. It actually didn't throw it away. It began to ignore it, and it created a new object that had the value 2. Because I, as an integer, that object was and is immutable. On the other hand, I, when it was a list, is mutable. That means it can change. Therefore, when I say I equals this value, and then I come down and I say j equals I, and I modify I, guess what? That object that we pointed to before, it's mutable, meaning it changed. And so that same object in Python's memory became 1, 2, 3, 4. And therefore j, which pointed at that object, is going to be the same. Now let's look at this picture I promised you. This is what I wanted to go through, and I'm actually going to attempt to present this so that we can get a little bit of an idea. So what I'm doing here is I'm taking you to other programming languages and the way that things used to work in the past. When you had a variable, you would typically, the way that the computer would work is it would take your variable name and it would point it to a piece of memory. And if it was a 32-bit machine, and this was in 32-bit integer, it would be pointing at 32 bits of memory. If it was 64 bits, it would be pointing at a 64-bit thing. In my olden days, which is way, way, way before any of you were born, I'm assuming I worked on a computer that was a mainframe computer that had 60-bit words, and therefore this was 60 bits. But whatever the size was, that variable name pointed at a piece of memory. So here I have I pointing at one piece of memory. I have j, I've arbitrarily done this, is pointing at a different piece of memory. I have a variable that I called average, and here in this piece of memory is a floating point number. Here, another piece of memory is actually a string made up of individual characters. So here, Chuck A. Black, you'll recognize that from my GitHub page, Twitter handle, etc. So this is how things used to be stored with traditional languages. Then we began to do things with what we called objects in C++, in Java, and in other languages. You had higher order or higher level objects. And when we deal with those, things are stored differently. So here we are, something that is not just a simple primitive, but it is something a little bit bigger than that, like an object in object-oriented programming. What you end up with in that situation is it still has a value. See this value here? That's going to be the same thing that you're looking at right here, whether it's an integer or floating point or a character or whatever it might be. But in addition to that, there's a whole lot of what we would call metadata and other stuff associated with that particular variable, which happens to be an object, because in Python, as well as these higher level objects in C++ and in Java as well, then you have something called an object. And in this situation, and I'm just putting stuff in here that may be part of your object that is storing that value. And that would be something called a reference count. I'll come back to that in a second. And a type. Oh, guess what? Remember, we looked at the type just a minute ago when we were here. Remember, we said, okay, what's the type of I? Well, type of I is class list, all right? Now down here when I said type of I is class int. Wait a minute, why is it saying class int? Well, I'm going to go back to what we were just looking at, and we will, if you have in the back of your mind the phrase everything is an object, then you'll have a hint at what's going on here. That's the type. In addition, since these things are objects, you can typically run functions on them. Now, functions in an object-oriented language are called methods. What's the difference between a method and a function? The only difference is that if it is an object and it is defined in the context of an object, then it's called a method. It's just exactly the same as a function for all intents and purposes. So certain things I could do to call to get information, I could say, what's the length of that thing? If it's a string, I could do a split or a strip. You remember, if it's an integer, I could get the absolute value. If it happened to be negative, I can get the floating point value. I can also do comparisons, so equal, not equal, greater than, less than, etc., etc. And there are many more of these. So this is the idea of an object. So when we say in Python, everything is an object, which, whoops, that's what I'm going to do right here. Python, everything is an object. In other words, there is nothing like we see over here. There's primitives that are available in Java and in C. Can't recall what they're called in C. That's like 20 years ago since I've used C or C++. Been using more Java and Scala since then. But the primitives, the way that we used to store everything, that's not what we're doing anymore. Everything is an object. So that's an important thing to be aware of. Now let me just point out one thing. In the way that things used to work with primitives in memory, you would end up, this is just storing things in memory. You would reuse it at various points in time. You can see that the cost is greater when you're dealing with things that are objects because you have a lot of memory. If you're familiar with C, then you're familiar with the function malloc to create memory to put stuff into. And you need to keep track of that memory, and you need to get rid of it at particular times. So you have to release it and give it back to be used for other stuff, whether that's called free or whatever it's called in a particular language. Once we got to languages like Java and Smalltalk and others, we began to see reference counts. So the actual system that was running your software would keep a reference count. So if somebody said I equals 1, the reference count for this object in the Python parlance, the value would be 1. The reference count went up by 1. And when somebody did something different to I, it would decrement the reference count. Now, if you're thinking about, okay, well, how does it manage its memory? How do you manage its memory? The answer is you don't have to manage your memory either in Java or in our situation in Python because it takes care of it for you. How does it take care of you? Take care of it for you by the magic of this reference count. As you can imagine, when the reference count goes down to 0, that means that nobody is referencing this object that was created. Then Python can get rid of it. It's called garbage collection in Java. It used to be an issue. Python is not really a language that you use for purposes of performance. People used to dislike Java significantly because garbage collection could happen periodically and cause things not to run in as fast a manner as you want. Python, you're not really that concerned about it. So just know that it goes on in the background, and that's why you don't end up with memory leaks of the same type that you do in other languages like C, because it's taking care of it for you. So This is what we mean about everything being an object. It doesn't matter if it's an integer or a string or a list or a dictionary or a class that you have defined or even a function. Everything in Python is an object, and that's what this means. Now, it becomes important when you come to the question about what is mutable and what is immutable, and that's what I'm going to show you on the next slide. So here we're talking about mutable versus immutable, and I'm going to draw a simple picture here. I'm not drawing all the extra stuff. We're in Python now, and this value that is 1 is actually an object, because in Python everything is an object. It has a reference count, it has a type, it actually has something called an ID, which is the pointer of where in memory this object is located. So you don't have to worry about that, but we're going to look at it just to see what's going on here. I'm going to do something very similar. What I'm going to do is I'm going to do exactly what we did in our discussion before when I was looking at Python from the Python interpreter. I'm going to go to the next item here, and I'm going to say j equals I. What does that mean? Well, you may not have noticed it, so I'm going to go back, and then I'm going to go do it again and look over here on the right. What did Python do? It said, okay, j is this variable name, and it is going to point at this same thing. Remember, what is this? In Python, everything is an object. This is an object with a value of 1. And it will have a type of integer, as we know. It will be located at a particular location. There will be methods that we can call on it, etc. Now, I said this before, and I'm not sure if you caught it. In fact, now I'm questioning whether I said it. But remember in our discussion of mutable versus immutable, an integer in Python is which? Is it mutable, meaning it can be changed, or is it immutable, meaning it cannot be changed? And the answer is, it's immutable. It cannot be changed. So when I go and execute this next statement, let's see what happens. So I say I equals I plus 1, and what's going to happen is this. Remember, because this is immutable, it cannot be changed. If I say I equals I plus 1, then what I have to do is create a brand new object, and now I points at that brand new object. And guess what? What happened to j? Nothing changed with j. J still points at the original object. And that's why j is still equal to 1 and I becomes equal to 2. Now, I don't have a slide for this, but let's think about our list situation. In a list situation, lists are mutable. So if I said I was a list and then j equals I, and I appended something to the list, both I and j would be pointing at the same list. And so it would still be the same. So you will get into problems at some point, potentially, as you become more of an intermediate or advanced developer, but this is something to be aware of. So let's get rid of this, and let's go back to where we were. So this is where we were. We were looking at this. Remember, I became equal to 2. J became equal to 1. This is what I was just talking about. If we look down at our list situation, the list was initially this. I said j equals I, so j and I both were equal to the same thing. Now I did an append to I, and I is a list this time, remember? And therefore, because it is a list and it is mutable, it just added another item to that list. And so now I has 4 items, 1, 2, 3, 4, and j, pointing at the same list because it's mutable, has the same data. Now the next thing I'm going to do is walk us through some code that I've written that demonstrates this in a little bit greater detail. Okay, so let's look at this code that I wrote to demonstrate the things that we've just been talking about. And at the end, I actually add a function, which is one of the places where you're probably going to want to be aware of what's going on with this mutable versus immutable, etc. So I'm going to use the debugger to step through this, since we learned in the last class how to use the debugger. So rather than looking at this one line at a time as I walk through it, I'm actually going to step through it and we can take a look at what's going on. So remember, here's my debugger. Here I'm going to be able to see my variables, but since I'm printing stuff out to the console, I just want to look at the console. And remember, this is step over, this is step into, so I'm going to be just hitting step over every time. So the first thing I've printed, as you can see down here, regular variables, integers, and strings, which are immutable. So I'm going to set I equal to 1, and then I'm going to print out I. Now, a little bit hard to see, but when I print out I, I'm going to print out the actual value of I using my fancy F string, and then I'm going to print out ID of I so we can see where that object is located. And the purpose for that is so we can tell if two objects are the same or if they are different. So I'm going to go and print that out. Here you see my value of I is 1. My ID is 4864. I'll just look at the end part of that. Now what I'm going to do is I'm going to say I equals I plus 1. So if I was to say what's the value of I, you would say, well, that's easy. The value is 2. And if I was to say what's the value of ID of I, then you would say either, well, it's going to be this value that you see down here, that won't have changed, or you'll say we have no idea what the value is because it had to create a brand new object. Because in Python, everything is an object, and as we mentioned, integers and strings are immutable, so it has to create a brand new object. So let's go down and print that out. And now we see, after I've printed this handy so I know, after I equals I plus 1, the value of I is 2. That's simple enough. Look at this value, 4896. So it is, in memory, what is that, 32 bytes further down in memory than the original was. So here you can see it doesn't matter what the value is. The important thing is to know that's different than this value. So this one, what's the reference count of this original I now? The reference count is 0, so it's probably already recycled it and put it into use, made it available for future use. This one, however, has a reference count of 1, as we mentioned. So let's go to the next line. You can see up here my next line is j equals 1. And when I print, now I'm going to print both I and I'm going to print j. So I'm going to go ahead and do 2 print statements here so we can look at both of them. And I'm not at the end, so there we go. Now I, the value is 2. This is what we saw before. Remember, it's the same as the value before. And now we said j equals I, so what did happen there? Well, j equals 2, we kind of expected that, but look at the ID of j. It's exactly the same as the ID of I. So j is pointing at the same location that I is. Now we're going to do our I equals I plus 1. And then I'm going to print these two things out again. Let me scroll down here. Now at this point in time, what is the value of I? It's 3. What's the ID? Where is it located? Oh, it's in a brand new location again. 4928. That's a brand new one. It's certainly different than this one. But what about J? So we haven't done anything with J in this situation. So J is still pointing where it was before, which is right up there. Okay, so that is immutable objects, meaning they can't change. And I will admit, when you think about it, when you think about integers and strings, you say to yourself, of course they change. We change them all the time. And it's true that you do change them all the time. However, in memory, what it means is that Python is getting rid of the old object that stored it and using a brand new one. That's why this ID for I is new after we've done I equals I plus 1. Okay, so now let's move on to lists, which are our example of a type that is mutable, meaning that it can change. So the first thing that I'm going to do here is I am going to say, let me just go down here. And print my list variables. I want to go down to the bottom here. And I'm going to say L1, which is my list number 1, is equal to, it's a pretty simple list. It only has one item in it. So that's my literal list. Remember, with the square brackets, that means it's data, and the square brackets means that it's a list. And then I'm gonna print this out. And there it's printing out the value. Here you can see L1 is printing it out, and then it prints out the ID. So the value is this list with one value in it. And the ID, notice it's a much bigger number. Don't worry about that. It just is stored differently, and the ID is used differently internally to Python, and it may be different depending on how every Python actual interpreter works in the background. But this is the value, so we'll look at the last 4 or 5 of these numbers here when we look at it. Now I'm going to say L1 append to, and I'm going to print it out. And now, as you would expect, here is my list with the square brackets 1, 2. The ID, you can see here, what's that value? It's exactly the same as the value it was before. Remember, when we did this with an integer, it was pointing at something different. The ID was different. Here, you can see the ID is the same. One thing I want to point out, it occurred to me, some people who are new get confused by this. Here I have square brackets. I say L1 equals this piece of data. When I do an append, I'm using round brackets or parentheses. Why is that? Well, the answer is I'm calling a function. The function is called append, and what you do with functions is you put in parentheses the parameters that you're passing in. So this right here is an entirely different thing than this. And so I'm appending, I put a variable name or a constant right there, whatever. All right, so getting back to our mutable versus immutable, here we see I've appended and the value is the same. Now I'm going to say L2 equals L1. Now I'm going to print out both of these again. And when I go down here, here's L1. That's what the value is. Here's L2. The value is exactly the same. And notice both of these, number 1, L1 is still pointing at the same location that it was, and L2 is also pointing at that location. We'd kind of expect that no matter what, because we just set L1 equal to L2, but what we're going to do now is we're going to actually append something to L1. And the question will be, is L1 going to be have an ID the same as L2? So let's step through this. I'm going to print my next line here. Here's L1. I've added something to it. You'll notice this value, the ID is the same, and the value now has 1, 2, 3 in it. Now I go to the next one. L2 also has 1, 2, 3, and lo and behold, it's also pointing at exactly the same thing. So in this situation, L1 and L2 have exactly the same value, whereas before with I and J, remember when we got down to the end, I and J were different. I've done effectively the same thing in terms of changing one, but not the other. So, and in the mutable situation, which would be where we used a list, they stayed the same, L1 and L2. And in the immutable situation, Python had to create a brand new object with a different ID and set it to the value 3. So here's the last thing that I want to do. And this is getting a little bit deeper into it. And this is a little bit more, why should I care? You may be saying to yourself, well, this is all new and different and nifty, and I'm glad I understand it now. You may even say, thanks for explaining that to me. But how is it of any practical use? I'm going to give you just one example where it may be of practical use to you. And so what I've done is I've defined a function. And this function has a regular variable and a list variable. So every time I go through this, I confuse myself. So I apologize for the kind of dumb names. But a regular variable is just an integer, and a list variable, as you might expect, is a list. I'm going to call and pass in a regular variable and a list variable, and I'm going to modify them, and then I'm going to return. And so this isn't the best programming practice, changing the value of parameters that get passed in. Sometimes people do it, and you should be aware of it. A better coding practice is to return the actual values that you have determined within your calculations inside the function, and return a value so that there's not the level of confusion that we're going to have here. But I want you to be aware of this. This is an immutable variable because it's just an integer, and this is the list, which is mutable. And so what I'm going to do is I'm going to call this, and I'm going to print out what the values are for the regular variable and the list variable inside, and then I'm going to print out what they actually end up as after we have called the function before and after. So let's take a look at this. Let's continue on down here. Function call, yeah, that's what this is. Here we are. We're about to examine immutability versus mutability. So I'm going to step through this. Python actually doesn't go in and execute that, but we will in a minute. I'm setting regular variable to 1, and my list variable is going to be equal to a list with the value 1, 2, 3. So I'm going to come down here, and I'm going to print out what these values are. The regular variable is 1, and the list variable is 1 and 2 and 3. Now I'm going to call my function. I'm going to pass in my integer, which is immutable, and I'm going to pass in my list, which is mutable. All right? So here's an example I can show you where I'm going to actually step into. So I'm going to if I were to do step over, it wouldn't go down into that function. It would just go to the next line. But I'm going to say step into. And here I am inside my function. Now I got passed a 1 and a 1, 2, 3. So what I'm going to do here is I'm going to set my regular variable, that's the integer, which is immutable. I'm going to add 1 to it. And then I'm going to take the list and I'm going to append the number 5. And then I'm going to print those out. So let's go down to the print statement. Now you can see our var is 2 and the list has 1, 2, 3, 4, 5. See how nicely PyCharm is showing me exactly what those are. That's kind of handy. And now it's going to print it out. I'm going to let it print it out. Not a surprise, that's what the value of regular var was, and the list variable was that when I left it. Remember, these are the things I passed in right here. I just passed those in. Now, my next line is I'm going to print out afterwards. So I'm done. What do you suppose regular var is equal to? And what do you suppose list var is equal to? Well, here's your hint. I can hover over it, and looking at PyCharm, the value is 1. Wait a minute, why is that value 1? I thought I added 1 to it. Well, remember, integers are immutable, and therefore Python is unable to change this actual value. So when the function calls it, it uses that 1. It says rvar equals 1 plus 1, so it sets rvar equal to 2. Remember, it printed it out in there, but now when it comes back, it's back to what it was before, which is the value of 1. Now let's look at list var. Remember, is that mutable or immutable? As you know, it is mutable, and therefore when I passed it in and we did an append, because it is mutable, it actually changed the value of my list. So here we have, in this situation, I've passed in an integer and I've passed in a list. I've modified both the integer and the list, and when I'm done, the integer that I passed in has not changed. It's at its original value, but the list that I passed in has changed, and it has the new value. And as we look down here, when I'm done, the regular var is equal to 1. That's what it was before I called. and the list var is equal to 1, 2, 3, 4, 5. So that did change. So as I mentioned, when you call a function, probably a better idea to have a return statement and then just incur the overhead of however many things you want to modify and pass back, incur the overhead of setting them when you return from calling the function. But if you do end up in this situation, or maybe somebody else wrote it and you're debugging a situation, remember, everything is an object, and mutability versus immutability is very important. Things like lists are mutable, and things like integers are immutable. In fact, if I were to go back to the slide that we're looking at, we're going to go and look down here. I actually give you some important things to look at. What are some things that are immutable? Integers are immutable, strings are immutable, and tuples are immutable. We haven't used tuples much. A tuple is exactly the same as a list, except guess what the difference is? You're looking at it. Tuples are immutable and lists are mutable. That means you can append an item to a list. You cannot append an item to a tuple. You need to create a brand new tuple with the appended item, and that becomes this constant immutable data. What about mutable things? Lists, dictionaries, sets, those are some of the regular types that you'll get used to using in Python regularly. Those can all be changed. So hopefully this helps you to understand a little bit about Python and everything is an object in Python, what that means. There's going to be something more than just a location in memory, but there's going to be a value with a reference count, a type, a bunch of methods, etc. You will understand a little bit about what it means to for something like an integer. When you change the value of it, what actually happens. You know a little bit about garbage collection, and you know about the code that we looked at, which can get you into trouble if you don't understand exactly what's going on. At higher levels of what you're doing when you build your own classes in object-oriented programming and you create static, you attempt to create static variables, this business of mutability and immutability will come up, and I know it's bitten me in the behind a time or two, so it's good to be aware of it. So hopefully for those of you who are new, you've understood a little bit of this, and you can just kind of put it in the locker in your brain, and you will be able to use it later. For those of you that are intermediate or advanced, you may run into this. It's good to have awareness of this and just knowledge of it as you go through doing your more intermediate and advanced Python programming projects. Well, that's it. Hopefully you enjoyed this lesson. You learned something that you didn't know before about how Python uses objects and how it is important to understand whether things are mutable or immutable. This will be hopefully something that is useful to you either now or at some point in the future. Now, at this point, I'm just going to go ahead and let Quokka start up and speed it up with some music. So yeah, thanks for listening. Hope you have enjoyed the lesson and hope that it proves to be beneficial to you in the future.